Yeah, good evening everyone. Chennai camps. So last thing we are doing was the introduction of this stress and strain stuff. So let's define this thing, longitudinal stress. So this is nothing but tension perpendicular to the cross-sectional area. So if you have a rod and you're pulling them, remember tension here is F. Tension is not 2F or 0. This is basically elongative stress. Same thing, if you try to push it from both the sides, this is a compressive stress. So the full name will be compressive longitudinal stress, compressive elongative longitudinal stress. So during this process, the length of the body would change. We call this thing longitudinal strain, which is delta L by L. Now be careful here. Delta L is the change in length from natural length. We will talk about that in a bit later. L is the natural length. Now, when you take a ratio of these two, what we find, this stress is proportional to strain. This is called as Hooke's law. The proportionality constant is given by Young's modulus Y, which is stress by strain. Others, keep your cams on. So Y can be written as tension by area by delta L by L. There, this is the formula. Which you need to remember. So this is the first mathematical thing there. So what is the physical significance of Y? The Y tells you higher the Y, you see, it means it requires more stress per unit strain. That means, see, whenever you think about stress and strain, simply think of like this. Stress means force, strain means elongation, just like a spring. But like I said, whenever you compare strengths, you always don't talk about, whether the elephant ka bone is strong or rat ka bone is strong. What you want to study is the amount of force it can withstand per unit area, isn't it? So whenever you're comparing strength, don't say force is more. You should say force per unit area. Same thing, when you say which material elongates more, for example, if I say, if you have 1 kilometer steel wire and if you have 10 centimeter rubber band, which can stretch more easily? I can actually stretch that 1 kilometer wire more easily by 1 meter than rubber band 10 centimeter to 1 meter. So that's a very wrong way of, saying who will stretch more. Instead of that, what you should study is per unit meter who will stretch more. That would have given you a better information. So whenever you think about stress and strain exactly and you're confused, think of stress as force and strain is like elongation. So higher the Young's modulus, more difficult to deform the body. That is a physical significance. For a rigid body, y is infinity because you can never stretch a rigid body. That's the physical significance. Have a look at this page. The one in the red box, that formula is important. All clear with this? So stress is simply tension by area. Don't say force by area. Because in this case, for example, if you look at this, if you say force, net force is zero here. Let's say a question. Turn in the page. We have two cylinders here. They are coaxial. This is radius 2r. This is radius r. This point is x is equal to 0. This point is x is equal to L, and this point is x is equal to 2L. So the total length of each cylinder is L. These are solid cylinders. Coaxial solid cylinders. Rho is the density. Plot stress versus x graph. What is stress? Tension per unit area versus x coordinate. Meaning, think of it like this. If I take this piece here, the tension here will be only this weight, na? If I take this piece here, the tension will be due to this weight plus this weight. Means as you go down, the weight is increasing, so the tension is increasing. So plot a tension versus stress versus x graph, where x is the distance from the top. Let's get this. Simple formula, stress is tension by area. That's it. Hope everyone has given the paper. Paper was tough. That was your
Yes,
seniors
sir,
का.
very tough.
Yeah. Oh, seniors का grand test का paper से निकाला था questions. Fine, it's a good thing it does tough. Now at least resolve and see what went wrong. At least now you will have realistic expectations about advance. Resolve. It's a good paper. I took some questions from Fiji IITs and from Narayana grand test. दोनों mix and match किया मैंने. For one paper, you guys are becoming like this. For your seniors, to from 3 months, I'm slaughtering them like that only. You'll get used to it. Utsaha ka computer to stopped writing paper only. It hated. It's like मुझे लिखना नहीं है. Everyone is able to see the questions, right? सिर्फ एक question को options नहीं था, right? The pulley वाला problem.
Yes, and there was no diagram as well for one or two questions.
हाँ. I don't know. Everyone else have same thing. I think ये सिर्फ अनुशक्ति नगर से problem I guess. I don't know. होता है the Chembur side thinks they don't like physics much. So system actually eats away the diagrams and questions. चलो इसका क्या करना है? This is easy records. First, let's say x between L to 0 means somewhere in the middle here. So if I take till here, then you'll take only this weight. Then tension T will be rho into weight of that piece pi x square into L. So stress will be pi r square into x. So stress will be tension by area, which is density, pi r square x by pi r square, which is rho into xg bhi rahega. Rho xg. That is your stress. This is the function from 0 to x between L. If you take x between 2L to L will be a discontinuous function there. That means if you take till here, means remember you're choosing this whole thing as x. Then this length will be x minus L. This length will be L. So for this guy, the tension would be density pi r square Lg, that is the upper cylinder, rho pi 2r whole square x minus Lg. This is the lower cylinder. The stress will be tension by area, but this time the area is pi into 2r whole square. So if you divide this, you end up with rho Lg by 4 plus rho g x minus L. So this thing is rho g x minus 3 rho g by 4. This is the stress in the lower cylinder. So if you plot the graph, stress versus x. So from 0 to L, use this function, which is a linear function passing through the origin. At x is equal to L, if you put x is equal to L in this, you will observe the value suddenly drops. So this value reaches rho Lg, then it suddenly drops from here and the graph will be like this. It kind of makes sense also. If you see the interface here, suddenly the area goes from pi r square to 4 pi r square. The stress will suddenly drop to 1/4 even though the weight is same. So what you have is a discontinuous function at x is equal to L. And eventually you will reach this value here, which is 5 rho Lg by 4. That's how the graph looks. So there's a sudden drop at x is equal to L and then increases. That's it. There's nothing in the question. You just have to find the tension. In this entire chapter, right, the main thing is about finding tension. If you know how to find tension, your job's done. Half of the question is over. Have a look at this. Clear? Any doubts on this? Next one. Udayan, Palak, clear with this. Rehan, Aryan?
So,
Clear?
so if you ask us for stress at x equal to L, we say it's not defined, right?
It's not defined. Either you tell me less than L or greater than L.
Okay, yeah, got it.
So we have a rod here. Here the force is 3F. Here the force is F. Here the force is F. Here the force is F. Each section ka length is L. Young's modulus is Y. And area is A. Find elongation in each section. Basically, you have to use this formula. Y is equal to tension length by A delta. If you know tension, you know everything else. Get this easy one, I'll give you a minute. Okay, easy one, just get it. First thing, find the tension. So if you cut the rod here, you can take the left piece or the right piece. So here the tension will be 3F. If you cut it here, the rod tension will be 2F. The whole system is in equilibrium. If you cut it here, the tension will be F. And from the formula, we can see delta L is nothing but tension length by AY. So just substitute here. This will be FL by AY, 2FL by AY, 3FL by AY. Hope everyone is clear with the tension part.
Sir,
Wherever you want tension.
I didn't get that. How did you write the tensions?
Wherever you want tension, cut it here. You will get the right piece or the left piece. Then draw an FBD. So what is the tension here? T should be equal to 3F because the whole rod is at rest.
But
You're
still
not
in
there
the
for that.
Okay,
second
sir.
one, like one is like compressing it and one is elongating it.
Where?
The second cross section, the forces. Like
So,
one force is, so that won't be the elongation now.
God, everywhere the tension is same. What elongation, what compression, what you're talking? There are two forces sitting here. What are these two doing?
Oh, right. Sorry, my bad.
Listen, you guys forgot, I guess some of you don't know how to take tension. Let's say if there's a force F here, right? And let's say this is force F here. How to find tension? Cut it. When you cut it, you'll get a right piece or a left piece. Then the tension should be T here and tension is T here and this is F here. It doesn't matter. Choose any one piece. Since it is an equilibrium, F is equal to T. Is that clear, everyone? Ishan, got the tension part?
Yes, I got it.
Clear? Yeah. Every rod, each section will have a different tension. See, for example, if I cut it here, then T is equal to F, or T is equal to 3F minus 2F. Either it will be F only. So we have mass M here. We have mass 2M here. This rod Young's modulus Y, A, length L. This is also Y, A, length L. Massless rod. M and 2M are connected to massless rods. And released from a horizontal position. So when they come to the lowest position, find the elongation in the upper and the lower rod when the rod becomes vertical. Find ratio of elongation in upper and the lower rod when it becomes vertical. Gravity is there. Since it is massless rod, the whole rod will have same tension. Matlab, this entire section will have same tension. This entire section will have same tension. If the rod would have had mass, then the tension would have been varied. We will see those kind of things later on. How do we do this? Three is to one. Nere. You guys are messing up the tension first of all. I'll tell you the first mistake what you did. You thought both have same speed. If this is V, this is 2V. Both will have same omega. Both will not have same speed. Isn't it? When the rod is rotating, what will you have? You have same omega. You don't have same velocities. Now try. That is where most of you must have goofed up. Loss in potential energy is equal to gain in kinetic energy. Then draw an FBD, get the tension. The question is literally work per energy and circular motion ka question. Once you got the tensions, you just have to dump it in the formula. So delta L is TL by AY Everything is same, so delta L is proportional to T. Indirectly I asked you the ratio of tensions. Try, got a minute. Four by three. I don't think you'll get a beautiful answer, right? So then this guy comes here. Let the speed be V. Let the speed be 2V. Because the rod will have same omega. So this guy is V is L omega. This will be 2L omega. This guy has fallen a height of L. This guy has fallen a height of 2L. Loss in PE is gain in kinetic energy. So here the loss in potential energy is mgl plus 2mg 2L. That is equal to half m v square, half 2m 2v whole square. 5 mgl, that will be half mv square. 4 plus 1, 9 by 2 mv square. P is equal to root over 10 gl by 9. Now, if you take the 2m ka mass, forces are tension T2, weight 2mg. Since it is going in a circle, I can take acceleration or centrifugal force 2m 2v whole square by L. If you take the mass m ka FBD, that will be T1 mg T2. Since you're going in a circle, we also have a centrifugal force mv square by L. So from here you'll get T1 is T2 plus mg plus mv square by L, and from here you get T1 is 2 mg plus 8 mv square by L. And we know from the elongation delta L is tension length by A y, so proportional to T. So the elongation in the upper rod delta L1 by delta L2 will be T1 by T2. I will leave the answer to you. Someone got 77 by 58, it seems.
So why are you ignoring the delta L in the work energy expression?
Yeah, it is too small.
But then, okay.
It's too small. You want, you can calculate and see. You'll go mad after writing 3 equations. Did you get, first of all, these equations?
Yeah, equations I got this, but with
You figured out all these things, the velocity part, the energy part, momentum part. Then fine, now you got it. Remember, generally the Young's modulus value is quite high, 10 to the power of 10. If you take a 1 meter rod, steel rod, let's say, you won't even get an elongation of 0.1 mm. So keep that in mind. Generally, elongations delta L is much less than L. Since Young's modulus is pretty large, we ignore that. Now, ये होता है ना, sometimes you guys overthink unnecessarily.
Sir, we can't be do it separately like 2m.
What do you want to do separately?
What 2m and m?
Meaning, what will you do separately? What to M and M?
The equations.
Say properly, Ray. What are you saying?
So he wants to write energy separately for both the rods, like separate equations for both the rods.
Third answer, different answer.
No, why are you doing that? Bolo na, reason batao na. Why can you do that? So what is your system exactly here? That means the rod connecting both of them. Then include the work done by tension on the rod also, na?
Okay.
Include, na. If you want to do them separately, MK, then include the work done by tension T2 on this rod and work done by tension T2 on this rod.
Okay.
You can't do that. That's why we take both the things as one system. And the drunkards, we have done this question in the class. That is the problem. You guys don't even remember. Question number 19, work power energy. 10 GL by 9. That is the issue. I need not give you new questions. What we have done, we can take that only and we can slaughter you. Next thing. Clear with this? Any doubts? The most common mistake that I see people doing is this part. They goof up here. Once you goof up, then the whole question is gone. So someone says 77 to 58. I don't know. Anyone else got that? So check it out. Let's see one more. This is a standard one. Top view. Mass M, radius R, Young's modulus Y. A is the area of cross section of the wire. The whole ring starts rotating with omega. We have done this in circular motion. If it rotates with omega, there's the tension in the ring. So find the change in radius. So once you start rotating the ring, because of the tension, the ring will expand. Find in change in radius delta r. Again, assume delta r is much smaller than r. Problem is, if you include even the delta r, right, you start getting a quadratic equation. Things get pretty messed up. And technically speaking, they're quite small also. If the radius is 1 meter, that elongation would be like 0.1 mm or 1 mm. Almost 1 by 1000, so it works out. Check it out. Get this thing. Why is the Young's modulus? Mass m, radius r. This is a ring rotating in a horizontal plane. First, get the tension. That's a standard question. I told you it will come in at least five to 6 chapters. The first time we saw this thing was in circular motion. Then we saw something like this in surface tension. This is the third time. You will see this again in waves. Then you will see in electrostatics. You will see again in magnetism. Try, got a minute. Like I said, once you got the tension, question is over. There's nothing there. The whole point is to get the tension. Remember how to take that thing? 2t sine d theta by 2 small elements. Yeah. Take a small piece. See, this is what I was saying. The moment I give a question like this, you should know what to do. Matlab tension kaisa nikalna, itna idea to aana chahiye. If you're not getting that kind of ideas, matlab your revision was not done properly. You forgot all the basics. And exam you can't expect speed. Exam every question if you're trying to do from scratch, you won't have enough time to do the tough questions. This is the angle theta by 2. This will be theta by 2. Theta by 2. This will be the centrifugal force dm omega square r. So 2t sine d theta by 2 is equal to dm omega square r. The difference between you and medical guys, na, by now they would have shouted the answer for tension. But the problem, they don't know what to do. They mug up the answers. You guys na can't mug up the answers and you think you're overconfident. Somehow I will derive in the exam. And I keep telling you this. If you can derive something in less than 45 seconds, there is no need to remember. You can't derive in 45 seconds, then remember. For small angles, this will become 2t d theta by 2. And dm is nothing but mass by total length, that is lambda into r d theta into omega square r. D theta, tension will cancel, m omega square r by 2 pi. That's your tension. Then we know Young's modulus is equal to tension length by A delta L From here we get delta L. That would be m omega square r. Length is 2 pi r by 2 pi y. 2 pi cancel, m omega square r square by ay. But delta L is nothing but change in circumference. So it is r plus delta r minus 2 pi r. Isn't it? Delta L is the total change in length of the circumference. This is not the change in radius. So if the initial radius is r and the final radius is r plus delta r, from there you will get this. Delta r is m omega square. 2 pi r will cancel. R square by 2 pi a by. Check. And like our assumption makes sense because y is 10 power 10 in the denominator, it will become 10 power minus 10. So delta r is quite small. Please check the steps. This is circular motion. And this is what I was saying. If you know how to find tension, question is over. After that, there's only one formula I taught you till now. Right, Sana, you got it. Any doubts on this? Didn't we do something like this in surface tension also recently?
So viscosity, right? Also
Surface
tension.
tension, God. Surface tension, right? वो string वाला problem, remember? Put it on a soap film, stretch होगा, ये question था, God. Surface
Oh, yes,
tension.
sir. Yes, sir. Yes, sir.
Viscosity में कहाँ पे pulling हो रहा है? Viscosity is just dragging you anyways. Clear? Next one. Next one is a good one. Important one, actually. You can put a star for this. We have a rod here, mass m, length L, area A, Young's modulus y, alpha. Alpha is the coefficient of linear expansion. Y is the Young's modulus, A is the area of cross section, blah blah blah. Ground is smooth. Find stress and strain when temperature changes by delta T. Okay, we have one answer. And I hope you know, Ajit, why that is the answer, the reason. He just didn't mug up. Then it is fine. Okay. Okay, most of you, I think you guys know the answer. I hope you know the explanation also. Then it is fine. Let's see. What is the answer? First of all, let's go back to little basics. What is delta L? What is this exactly, you know? So whenever you expand a rod, if you go back to thermal expansion, I wrote a statement there. Look at this thing. Here. Whenever the temperature rises, why is the first place the rod is expanding in the first place? Whenever the temperature increases, the bond distance increases, right? And therefore, the rod will, you know, the molecules push each other, creating the new extra length. That means at this new temperature, L plus delta L is the new natural length. The reason why the rod is expanding is because it does not want to have any internal stresses. So the important thing you need to understand, there's a difference. The delta L in the strain and the delta L in thermal expansion are completely two different quantities. So whenever you take a rod here, length L, temperature T, when the rod becomes L into 1 plus alpha delta T, when the temperature is T plus delta T, this is the new natural length. You're getting it? Whereas in the strain, when you write this delta L by L, right, this delta has a completely different meaning. This is the change in length due to inter-external forces. Getting it? This is the forcible, someone is forcing the length to change. Change in length due to the external factors. Think of like this. Suppose if I catch your cheeks and pull them, you feel stress. But let's say you eat a lot of food and become fat and the cheeks become big. You don't feel anything, isn't it? Because when you eat a lot of food and you become fat, the cheeks are become bigger, but you don't feel stress because that is your new natural length of your cheeks, isn't it? But you feel stress when I catch them and pull them because that is not your natural length. I am forcibly trying to expand them. Are you getting the catch? So in the strain curve formula, when you take this delta L, so what is the final length? So the final length is L into 1 plus alpha delta T. What is the natural length? Natural length is also L into 1 plus alpha delta T. So for strain, what is delta L? This is the change in length from natural length. So the rod will think I didn't expand only. This is my natural state. No one has forced me to expand this. I have become big on my own. Are you getting the difference? This is the change in length from natural length ka difference. Therefore, in this case, delta L is 0. So strain will be 0 by L into 1 plus alpha delta T. The denominator is also strain is 0. And we know stress is equal to Y into strain. Strain is 0, so stress is also 0. This is what I was saying. If you eat too much and become fat on your own, no one is expanding your body. You don't feel any stress. Right? But if someone catches you and starts pulling your cheeks, you feel stress. That's a forcible elongation of your cheeks. I hope you're getting the difference between the delta L's in thermal expansion and delta L in this. Both are completely two different things. So don't mix it up.
So here we said stress was 0 because stress is directly proportional to strain, right? It's not like stress by strain is Y.
No. Y is a constant, right?
Right. Got it.
Delta L in thermal expansion and elasticity are completely different. Don't mix them up. Just keep that in mind. Let me show you a counter question to this that will make things even better, more clear. Clear with this? So this was a straightforward question in mains. So the other format of the same thing, this will be better. Let's say we have two walls. Friction is mu. These are rough walls. Gravity is also there. So someone kept a rod in the middle. Mass M, length L, area A, Y, and alpha. This is also mu here. So rod is loosely fitted. Meaning if you leave it, it will just fall down. It is touching the walls, but it is loosely fitted. Find the change in temperature so that the rod remains in equilibrium. So if you increase the temperature, the rod will try to expand and it will push the walls. So you get normal reaction, you get friction. Find delta T. if rod remains in equilibrium between the balls. Get this. We'll wrap up this chapter next class, and I think next Friday you have a major test, right?
Yes, sir.
What are the portion in that? They have extra what? Gravitation, electrostatics.
Yeah.
Waves is also there.
Waves is also there.
You guys solved all the booklets complete कर लिया क्या उन सब chapters का?
So we
They're just
doing in pace.
They're just finishing all the portion, मतलब chapter खत्म कर रहा है.
It means only half of it is done.
यार क्या रह रहे हैं वो लोग, क्या फायदा? But again, I'm telling you, at least when I teach you, do finish your pace booklet properly. Again, I'm telling all of you one thing. We will wrap up the portion by October and November first week. When the portion gets over, and when I ask you, did you finish your pace booklet for all the chapters or whatever your classes ka material? You should say, yes, sir, we finished everything. If you have not finished all the material, I'm telling you, you will be in a big soup. अगर नवंबर तक if your booklets are not done properly, right, उसके बाद you have to start your mains का revision and mains का PYQs and mains का papers. During that time, if you're still sitting and doing a booklet, biggest problem, again, I'm telling you, don't try to achieve perfection. Don't go for perfection. If your booklet is there, level 1, 2, 3, 4, and let's say you feel 4 and 5 are really hard and advanced questions, at least 1 to 3 to complete karo. Right now, your job is every chapter, you should be at least 80% confident. What is happening with your seniors, I'll tell you. Most of them, right, there are 20 chapters. They did, 11 chapters very well. 9 chapters इतना खराब था, the moment they see the chapter, they start getting scared. Sir, ray optics ना मुझे देख के डर लगता है. Now the problem, you know what? When you have a fear like that, even if you have 1 month, you'll not be in a position to study. Instead of that, if you say, sir, 7 chapters, I'm pretty good, right? 12 chapters, I'm okay. मतलब mains level तक कर सकता हूँ, but tough questions I can't do. 1 or 2 chapters I can't do. Now this is fine. We can work on these 12 chapters. 2 months we can cover up everything properly. Problem with the perfection is what? When you try to perfect a chapter, it takes a lot of time. Getting it? When you go from 0 to 80, when you take it from 80 to 100, in this time, you could have done another chapter from 0 to 80, 2 more chapters. So what you're fighting here is time. What we are trying to do is not perfection, but optimization. Simple thing. In your first attempt means if you don't score 98 percentile at least, you yourself will give up on advance. Getting it? So if you're dreaming about advance, first you need to cross at least 98.5. 98 also you will cry actually. If you're not scoring 99, you yourself won't feel confident. And like I told you, 99 percentile कुछ super rank नहीं है. 99 percentile is 12,000 rank. The 99 number looks good. That's it. There is a parent who said like, sir, my kid got 91 percentile, उसको advance में train करना है. The poor parent didn't know. He thought this was a percentage of marks. ये एक था. दूसरा parent 94% था. This happened 2-3 years back. He called up and said, sir, my son cheated in the exam. I said, sir, what happened? Sir, वो इतना नालायक है, चांस ही नहीं 94% आएगा नहीं उसका. Kidding है. I don't know how he got 94%. He must have done some kind of thing. Then I told him, sir, वो 94 percentage नहीं है, percentile है. Sir, I don't know what is that. Then I explained him. Sir, if there are 10 lakh students, every 1% is 10,000. So 94 percentile मतलब 60,000 rank. The parent is like, oh, okay. Then he suddenly became happy actually. Like, my son didn't cheat. My assumption that my son is an idiot is right. So matlab, assumptions were satisfied. The father was happy. He disconnected the call with some happiness. I gave him something to cheer about. So yeah. So keep that in mind and study. Make sure you finish your booklet, HCV, jo bhi kar rahe ho material. Take one book. This is what I'm telling you from day one. Take one book, finish off end to end properly. Don't jump between books. When you jump between books, you know what you do? ये आज ही हुआ था. One of the seniors, your batch only. This guy was doing HCV, right? HCV is just, let's say there are 60 questions SHM ka. He's doing 1 to 30. Uske baad he's finding the questions difficult. Then he goes to DC Pandey. He does level 1 to 30 questions or 40 questions. Then he finds it difficult. This idiot is doing all easy questions from 3 books. End of the week, he comes and tells me I did 150 questions. So mentally, he's satisfied. मैंने बहुत solve कर लिया. He left all the good ones. In every book, he was doing the starting 15-20 questions, starting 15-20 questions. What did I use? This is a mental satisfaction. I did 150 questions, which is useless. You should have done that HCV का 60 questions अच्छे से करना चाहिए था. All the learning would have happened in the last 30 questions. You ignored them. And he comes and cries, sir, मुझे marks नहीं आ रहे. क्यों आएगा? Every time there's a difficulty, you plan to run away. A tough question is an opportunity to grow. हमको ऐसा नहीं लगता है. We think like tough question मतलब oh there's something wrong in life. And you guys want to go to IIT and solve big problems. So point क्या है ना? You don't become awesome after going to IIT. Become awesome now. Then you'll go to IIT. What is the catch here? Let's see. So when you increase the temperature, this is the scenario. The rod will think, let's say normally your shirt ka size is M. You wore it today, comfortable, happy and nice. Next 6 months, you ate a lot of food and you become fat. Then you wore the same shirt. What will you feel? You feel like, "Arre, tight ho gaya." The thing is, now when the temperature has become T plus delta T, your natural length is L into 1 plus alpha delta T. The rod thinks I was supposed to be L into 1 plus alpha delta T. So your shirt size has become L. But because of the walls won't let you expand. The length is still L. Due to walls, the length does not change. So the rod will think someone has compressed me by L alpha delta T. Length remains L. Now, are you getting the difference? Therefore, the rod feels I was supposed to be L into 1 plus alpha delta T, but I'm still L. Rod feels it got compressed. By L alpha delta T. Hope you're getting the difference. Now, if you take the rod ka FPD, so the rod is being pushed by N from this side and N from this side. So tension in the rod is also N. I hope you remember this. Zero nahi hai tension. Then use the formula Young's modulus is equal to tension length by A delta L. So Y A delta L is L alpha delta T by L. L is the natural length, which is L into 1 plus alpha delta T is equal to the normal reaction. Since alpha delta T is very small, we neglect this. Remember, alpha ka value is 10 power minus 5. From there, we get the normal reaction is Ya alpha delta T. So on the walls, there will be two frictions also, F and F. And that will balance mg. So from there, we get 2F is equal to mg. F is equal to mg by 2. But we know friction ka value is always less than equal to mu into n. So from there, we get delta T must be greater than equal to mg by 2 mu Ya alpha. That's your answer. As long as the temperature is minimum at least this much, you're safe. I hope you're getting the difference between the previous problem and this problem. In the previous problem, when you increase the temperature, length became L into 1 plus alpha delta T, and the rod is happy. He said, this is how I am. But in the second case, the rod, right, when you kept it between the walls, the natural length is L into 1 plus alpha delta T, but you didn't let the rod expand. So it is like you're wearing an M shirt and you start eating food every day, and after 6 months, you become fat and the shirt suddenly becomes tight. So your natural length has changed. It is not M anymore, it is L. That's what happens with your clothes. But currently, next 2-3 years, you won't have this kind of problems. Once you reach my age, you will see. At your age, whatever you eat, you generally grow vertically. My age, you grow horizontally. So, have a look at this question.
So here there won't be any shearing stress because the forces are balancing over.
Yeah, forces are balancing out.
Okay.
Clear with us? Any doubts on this thing? Now here, the stress is coming because of temperature. So therefore, we call this thermal stress. Since rod is under stress due to temperature, this is called thermal stress. We couldn't do this in thermal expansion, so we are doing it in this chapter. Since rod is under stress, due to temperature, we call it thermal stress. Clear? Next one. Next one is a good one, Ray. This should be a good advanced question. Top view. So we ignore any gravity. There are two walls. You kept a rod here. You kept one more rod here. So there are two rods here. L1, A1, Y1, alpha 1. Length is L2, area A2, Young's model is Y2, quotient of linear expansion alpha 2. Everything different. This is your interface. Now, when you increase the temperature, find the distance moved by the interface. Now, if you increase the temperature, one of the rod will be strong. Whoever is strong will push the other guy. So interface can move. There is a possibility it will move. Find the distance moved by the interface when the temperature changes by delta T. So the previous case, right? That is the reason. Ever seen this thing when you go on a flyover? When your car is going, tuck, 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 it keeps on hitting this. You keep getting the sound. When you actually see the road, you'll observe the flyover, right, has small gaps in the middle. That's not a construction fault. They actually leave that slight gaps in the middle because due to summer, right? During summer, the bridge actually expands. You need some space for the thing to expand over. If you don't leave that space, the concretes will push each other and things can get pretty bad. You start getting cracks in the building. Same thing with the railway tracks also. They leave, small gaps. You will observe this thing on, roads also. Which roads? When they make cement roads. Happens in India. It happens everywhere. In India, we can get to see more. Or kuch nahi hai. Temperatures are more, na. If you see in cold countries, they have other problems. If you see there, glasses break actually. During cold winters, what happens? The surrounding frame will shrink, but the glass won't shrink. So glasses will crack. In India, we don't have that problem. Their pipes crack. We will see that thing later on. Cold has its own problem. Temperature has its own problem, but temperature is better. Where is this? Thermal. There. This is what can happen to tracks. You don't leave proper gaps or something, the metal will start bending. Tracks can become like this. The stresses developed are too huge. Let's get this now.
So you want the distance in terms of the variables given, right?
Yeah. L1, A1, Y1, alpha 1.
Yeah, okay.
How do we do this? Simpler question will be like this. When the temperature increases, which of the following options are right? Okay, the left rod and the right rod both are compressed. The left rod is compressed, right rod elongates. The left rod elongates, right rod elongates. This elongates, compresses. ऐसा 4 options होगा. That would be an easy version of this. Heat, movement. What is that, Rotsa?
Never mind.
So, but this also you can only tell when you know the values like numerically, right?
Yeah, you can tell. Chalo, what do you think are the options then, at least?
मतलब
If you have
देखने
to
से पता-
eliminate, which options you'll eliminate?
A
So
तो
A and
I think-
C.
Yeah, A and C.
चलो तो 2 options तो है ना, देखते what happens. Try, I'll give you a minute. L1, Y2, A2. Yeah, you might be right, Rakshika. In this question, the most important thing is drawing the diagram properly. See, if we draw the diagram, so this was the initial position. Okay. Now let's understand like this. Let's say the right side rod is not there. If the right side rod is not there, this guy was L1 and this guy was L2, the left rod will do what? The left rod would have expanded till here. Isn't it? And this length will be L1, alpha 1, delta T. If the left rod is not there, the right rod would have expanded till here. And this would be L2, alpha 2, delta T. So you need to understand, the rods will think we were supposed to be this much, isn't it? If the other guy was not there, I would have been this much. But let's say the final diagram, I'm assuming it has gone to the left. This was your final diagram. Okay? This is the final diagram. This is the x which we are trying to find, the distance moved by the interface. Now, if you ask the L1 rod, what will say? L1 will say, I was supposed to be this much, but because of the compression, I got compressed this much, and I also got compressed this much, isn't it? You get the catch? You were supposed to be that much, but you became like this. If you ask the second rod, it will say, I was supposed to be till here, but because of the compression, I got compressed till here. Are you getting the catch? Both the rods are compressed. The mistake you guys were thinking is one is expanding, one is contracting. That is a wrong way to see. It is like, if I push you, you're getting compressed. Even I'm not, even I'm also getting compressed, right? It is always a comparison. If you are not there, I would have gone from 1 to 1.5. But because you are there, I went only till 1.3. I lost 0.2. Are you getting the difference? When you say compression or elongation, it is always measured from natural length. It is not measured from your initial length. I hope you're getting the difference. When the temperature increases, L1 and L2 are not the natural lengths anymore. So in this rod, the elongation E1 will be L1 alpha 1 delta T plus X. In this guy, the elongation E2 will be L2 alpha 2 delta T minus X. In both the rods, what is same? Tension is same in both the rods because it is an equilibrium. So the formula would be Young's modulus is tension length by A delta Y, A delta L. So tension is same. So tension will be YA delta L by L. So if you substitute the formulas Y1, A1, delta L1 is the first elongation, which is L1 alpha 1 delta T plus X by L1 should be equal to Y2 A2 L2 alpha 2 delta T minus X by L2. Rearrange the terms. Bring all X to one side. This would be Y1 A1 alpha Y2 A2 alpha 2 minus Y1 A1 alpha 1 delta T by Y2 A2 by L2 plus Y1 A1 by L1. This is your X. So how do you know which rod will dominate? It depends on the product of YA and alpha. Whoever has a bigger product YA alpha, that guy will dominate. Have a look at this. So the main catch in the question is figuring out this thing. Both the rods are compressed. The measurement is always taken from the natural length. Y1 A1 by L1. You're right. Please have a look at this. It's a good one.
Sir, what did you take E1 and E2 and please explain again? वो नहीं समझा.
E1, E2 are what? They are the compressions from the natural length. What is the natural length?
L1 plus L alpha 1 dt.
So this natural length, extra length plus X got compressed ना. Initially rod का length
Oh.
कितना था? सिर्फ L1 था. So if you would have been, this is the extra length plus this length also got compressed.
Oh, okay.
Got it? For
Okay,
the
yeah, I get
bottom
it.
one, bottom में क्या हो रहा है? Bottom में the rod would have been till here. Means your natural length would have been extra L2 alpha to delta T. That is extra.
Yes, sir.
But in that you got compressed only this part.
Mm-hmm.
Making sense?
Yes, sir. Yes, sir. Got it. समझा.
Everyone got the diagram? If the other rod was not there, L1 would have been till here. This was the natural length. But because the other rod is there, you have to compromise and you stopped here. So all that shaded part got compressed, which is L1 alpha 1 delta T, that length due to temperature plus extra X. Clear, no, Yasha? Got the diagram? Palaksh? Ali? Udayan?
So like this is actually like on the fixed end there won't be any compression due to the it being fixed like on the other
This
side.
is inclusive of everything.
Acha, okay.
Inclusive of everything. How do you know which side? The compression is actually happening every point, isn't it? This is inclusive. Clear? Everyone got this? Great. Next thing. Now, if you have forces, you also have energies. Or you can say elastic potential energy. So consider we have a rod Y, A, length L, and let's say someone is applying an external force F. So this is the natural length. Now, once you start pulling the rod, The rod will start stretching, let it be X. Now, in this scenario, the external force is still pulling with F, but now you get a tension in the rod. This is the tension force. Now, this tension will depend on Y A. Tension would be Y A X by L. So the tension in the rod will depend on X. Isn't it just like a spring? The spring force doesn't depend on how much you're applying from outside. The spring force depends on how much is got elongated. This is the tension. This is your intermediate state. Eventually, the rod will reach an equilibrium state. Elongation E. At this scenario, the external force F will become equal to the tension. So T becomes equal to F in steady state. So be careful, F is not equal to tension every time. Now, when you write this formula here, E will be equal to FLY AY. Now, here, if you take the work done by the internal forces or work done by tension, since the tension is variable, it is minus integral T into dx, minus because both are in the opposite direction. And we know work done by internal forces is negative of change in potential energy. Minus minus goes off. You will end up with YAX dx by L. This will go from 0 to E, and this is the potential energy. The change in potential energy would be YAE square by L. Now you can adjust this to L. There are multiple ways you can write this. You can write this thing as 1 half YA by L into E square. If you see, this kind of looks like delta U is equal to half KX square, isn't it? So that YA by L actually behaves like a spring constant. That is the easiest way to remember the formula. And that is the reason, if you see here, Y into A is K into L, that's why this was constant. So whenever you cut a spring, Y won't change, A won't change. This is where we got that, spring equivalent ka formula from. K into L is constant whenever you cut a spring, because Young's modulus won't change, area of cross section will not change. This is one way of writing it. Or you can also write delta U is half YAE by L into E. This is half into FE. Have a look at this. Let me show it in the next page.
So as you're expanding the rod, the center of mass is also moving, right? Because of the
It does move.
okay.
हो जाएगा ना, center of mass will be where? If the rod is uniform, the center of mass will be at the center of the rod.
So there could be like an elongation where the rod starts turning because the torque due to the weight and the torque due to the this thing will become unequal.
So what is that thing and this thing and
The
which thing?
friction, matlab, what's holding it up in that?
Now, just imagine if I try to explain the same way you try to give the question, na, you'll feel like, sir, what are you talking?
So it's okay, I'll ask you after class.
इसमें कुछ rotation आने का chance ही नहीं है रे. How will you rotate this thing? The force is along the rod, F and T. Where are you getting that rotation from? Where are you creating torque from?
So it's okay, I'll ask you after class.
So when you guys are asking a question, please try to use normal human language. Don't use baby language. There is one guy who was asking like that. Sir, in that question we did like that, and this happened now. I said, when that happened now, because of this only that thing happened. He's like, sir, आप क्या बोल रहे हो? I said, exactly. That's what I'm also saying. Exactly, तो क्या बोल रहे हो? That thing, this thing क्या होता है? मतलब मतलब if you say that thing, this thing, it's a question. If I say that thing, this thing, I'm making fun of you. मतलब half Fe, getting it? So this can be written as half into F by area, E by length. I can also multiply A into length. So this formula becomes, so this is your elastic potential energy, force by area is stress and E by L is strain. Half stress into strain into volume. I don't like this. There's a better way of writing this, which is actually quite useful. Half stress square by Young's modulus into volume. How did we get this? I just replaced strain with, y is equal to stress by strain. No? I replaced it. Strain with stress. I will see why this is useful. The biggest problem with this formula, right? This is valid only when tension is constant. If the tension varies, you can't use this formula. So these are all the different formats you have. Half Fe, half stress into strain, half stress square by this thing. All these things will work. Now, if you observe something here, the heat produced, what is work done by external force? The work done by external force is force into displacement of point of application. What is the energy stored? Half Fe. Therefore, the heat produced will be, so whenever you're stretching this rod, technically speaking, the rod should start oscillating, but it doesn't oscillate. That means half of the energy is lost. And if you remember, I said the same words, in surface tension. Capillary action may also, you lost half of the energy. There is always this tendency, in natural systems we observe, you always lose half. We will see this kind of phenomena happening in surface tension, capacitors. We will see this thing in, again, elasticity. So this is another thing. So whenever you try to stretch a rod and when you reach equilibrium, you produce the heat. So whatever you did, only half of it is actually used to elongate and remaining half is gone. So this is the problem with the natural system. That means whenever you're trying to charge a battery, you lose 50%. You're getting this problem? In the most efficient, hypothetical, natural case, you still lose 50%. That means whenever you try to charge a battery, even if you make the most ideal battery, you lose 50%. And then when you try to discharge, you lose another 50%. In reality, you get 25%. That's why saving power in a battery and trying to reuse them is one of the most hopeless things. And on top of it, there are other inefficiencies. So in reality, if you charge it with 100 joules, you might get back like 12 or 13 joules. That's why storing energy is a problem. People don't notice it, but what is the biggest issue we face? You can't store electricity. Right now, whatever power we are using right now is being produced at this instant. That is a problem actually. And if you think about it, during night time when people are all sleeping and all, the power consumption actually goes down. The power generators are free. If somehow you can store energy, generate power in the night, save it and use it in the daytime. We can't do that. Highly inefficient, so it doesn't work out. Clear with this? Now, what happens if tension is variable? This is an important one. So if you have a variable tension situations, this is what we do. You can put a star. So if you have constant tension, if you see this whole chapter, right, these are the two main formulas. If you have a constant tension, this is the formula for elongation. E is equal to tension L by AY. Energy stored will be half Fe or stress square by strain. Stress square by Y into volume. So use these formulas. If you have variable tension, let's say somehow you're able to find the tension as function of X. So this is the concept we do. We have a rod. So at a distance X, to take a small dx, the dx is so small, we can assume tension is same. So in that small dx, we get a small elongation dE. So dE is elongation in that small dx rod. Since dx is very small, we can assume tension is constant. That's the whole point of integration. For that small section. Okay, throughout the rod it is not constant. For the dx it is constant. Then your formula becomes dE. So the still end of that you still have to use the same formulas. dE will be tension T of x. Length ka place mein you get dx by ay. So this is the formula for elongation. So E will be integral your tension as function of x into dx by ay. That will give you the elongation. And your energy stored will be, this is the reason why I said I like this format of writing it. Because if you see stress depends only on tension. T of x by area square, that is your stress square, by Young's modulus A into dx. A dx is the volume in the small section. Tension is a function of x by area, that is the stress square by Young's modulus into A dx. So if the tension is variable, use these formulas. Have a look at this. So the main thing is you only know these two formulas. So if the tension is varying, somehow we have to manipulate these two formulas to use them. So what we do, we take such a small dx, you can assume tension is constant. So you can add all the small elongations, you get the total elongation. Same way, you can add energy in that small rods and add it up. Put it on. Take a break. Come back to 7-2. You continue from here. Now, Arjun, bolo na. How do you want to twist the rod?
So actually, my doubt is something different. Only. Why does like a rod bend? Like in that
When?
the way you're
That
drawn
is due
it.
to a different thing. If you keep pushing like this, you're saying the rod will become like this, huh?
No. Like it becomes like this now, like a curve when you suspend it as a horizontal.
That is because of your weight, Nare. Because of the mg
exactly.
here, every point is that will stretch. That's a different thing. That the
That's
rod will sag.
yeah.
What we are studying, this is different. This is a factor of shearing strain plus longitudinal. Both are there. We don't study this.
Okay.
That's very complex. वो बहुत weird equation आएगा. We don't have in the portion. If you're a mechanical engineer, you'll study that.
Okay.
Anything else in today's class? Any doubts? Take a break. Come back with 7. I'll see you in 10 minutes. Chalo, let's start. Question 1. Chalo, cams on everyone. Let's see a question. So we have a rod here, mass M, length L, area A, Y, and someone is applying a force F. Ground is smooth. Find elongation and the energy stored. Now variable tensions. It does elongate, right? There's a tension in the rod. Initially there's no tension. At every point there's a tension, isn't it? So each part of the rod will elongate. So you mean to say, right, if someone catches you and drags you on the floor, you don't feel any tension, you're happy. You feel comfortable. You feel comfortable, right? You feel discomfort. The discomfort is actually the tension in your body. You still don't believe that you should do that. Always, whenever you get confused now, exactly what is the FBD, imagine you are that body there. You will immediately realize what is happening. Humans have the tendency to figure out stuff when it is about you. When it is about some random rod on the floor, we don't care. But if I say this is you on the floor sleeping and your friends are dragging you like this, you will feel it. Your hand is under tension. Your body is being dragged. Everywhere there's a discomfort. The only comfort you'll have is your legs because the tension is zero. The tip of your legs will have T0. How do we do this? E power exponential. Exponential कहाँ से आएगा? God, just want to give you a general formula here. First, find tension as function of x. Right, Lakshika? That is right. How to find tension? You guys forgot. Where are you? I thought you somewhere here. Here. These questions, remember? How to do this kind of problems? Step 1, find the acceleration. Step 2, wherever you want to find tension, cut it there. Then you get two pieces, the right piece or the left piece. Take any one of them. Draw the FBD. Then F minus tension is mass into acceleration. That's what I said. If you know how to find tension, this chapter, half of the questions will be done. So you're pulling with F. This is your acceleration. Acceleration is F by M. Let's say at a distance x, you want to find tension. So cut it here. I will take the right side ka part. So this is F. This is tension. This is acceleration. Now this mass will be total mass by length into x. We have F minus T is equal to mx by L into A. A is F by M. So we get tension is F into 1 minus x by L. That's your tension. Once you got that, what is elongation? Integral tension T dx by Ay from 0 to L. Substitute that. That would be F by Ay integral 1 minus x by L into dx from 0 to L. You end up with FL by 2Ay. You want energy. Same thing, half tension by area whole square by Young's modulus into A into dx from 0 to L. One area ka term will cancel. You end up with 1 by 2Ay. This would be F square integral 1 minus x by L whole square dx. That is actually x power n ka integration. Someone solved it? Yeah, Lakshika, I think that is right. F square by 6 Ay L. That's your answer if you integrate. Check it out. That's what I'm saying. Once you got the tension, question is over. You just need to put it there and integrate. Have a look at the steps. Limits you need to apply. Can we say that applying the force F is equivalent to applying F by 2 on both the sides? Nope, it is not same. If you apply F by 2 on both the sides, the tension will be F by 2 everywhere. The tension is varying at each and every point. What if I ask you like this? It doesn't work for energy method, you will mess up. Maybe you're trying to say that because the answer is looking like that. Don't do that. Because the answer looks like that doesn't mean it is right. But actually it works. But you should know when, till what extent it works. What Ishan is saying, there's actually a trick. This is what I teach for medical students. I teach them this only. If you have a rod here, and let's say the force is F1 and F2. So in this, we can find the T average is F1 plus F2 by 2 because they don't need integration. Even at a mains level. Suppose if this was F1 and this was F2, here the tension average will be F1 minus F2 by 2. Then you can simply apply elongation will be tension average into L by Ay. You can use this average formula and finish it off. The only reason it works is because elongation is a linear function. Are you getting it? Whereas energy is a square function. It doesn't work. Average methods work for linear functions. If you know that, and you can do that, or else you can't do that. Clear with this? So you can remember the shortcut. It actually helps, saves you time in the exam, mains or bits. If two forces are given F1, F2, this thing actually accelerates. No need to integrate. But don't use this for energy. If they ask you energy, you're dead. You literally have to integrate. Please have a look at the steps. Clear, Shan?
Yes, Satya.
Others, any doubts on this, please ask. So if you see the main thing was getting the tension. Let's see one more. Next one. We have a rod here. You're applying with F and you're pushing from F. Mass M, length L, area Y. Find elongation and energy stored. Okay, get the energy stored. Okay. Elongation will come 0 gods. And pretty interestingly, you'll get 0 actually. Exam they'll ask you like, the rod is not elongated. That statement is wrong. The rod is not compressed. That statement is wrong. Something interesting happens to the rod, but let's see. I'll show you. Take a minute. If you look at the tension in this rod, acceleration is 2f by m. Cut it here at a distance x. This would be mx by L. F minus t is equal to mx by L 2f by m. We get tension is 2f into 2 minus x by L. So the interesting thing about the rod is the front part of the rod is actually having a tension which is elongation. The front part of the rod is actually getting elongated because it is being pulled. And from the back part, since you're pushing it, the back part is actually getting compressed. So the mistake here is thinking that the rod is not elongating. The rod is actually elongating the front part. The back part is compressing. The net elongation is 0. Clear? So the rod is actually under stress. Think of like this. You're there. One of your friend is pulling you from the front and one friend is pushing you from the back. Your front hand will actually stretch, whereas your back part is actually getting compressed. So the rod is not, it's not a natural length or something. So when you take the total elongation, it turns out to be 0. F into 2 minus x by L dx by ay. But don't think the rod is in natural state. So exam they can ask you like that. They can ask you find the elongation in the first half of the rod. Then you'll go on. You can't say the whole thing is not in natural length. Rod is not in natural length. Understand that much.
It always divides exactly in the middle.
In this case, na FF equal to diya. Symmetry to hai. And for energy, the formula is still valid. Energy, we won't have a problem. It's a square. So R to A. This would be F square 2 minus x by L whole square by A square A dx.
So
Anyone
it
solve
should
this by
be.
any chance?
So I think the tension should be F into 1 minus 2x by L.
1 minus 2x by L. हाँ सही बोल रहे हो. I wrote wrong. So you integrate this thing. Anyone got an answer for this? F square by 3, F square by 6. Integrate. Anyone got this? I will leave it to you. You can integrate this much though. But clear with the steps. Let's see one more. 6a by k. I'm not sure. Verify your answers. 2 people have said the same though. Turn in the page. So like I said, once you got the tension, it is finished. But this rod is interesting there. Even though you get elongation is 0, rod is not a natural hit. We have a rod hanging from the ceiling. Find ratio of energy stored in the upper and the lower half. Get this thing. Let's get the ratio everyone. Seven is to 1. Okay. Maybe. We have one answer. Anyone else got 7 is to 1? See? So energy in upper half will be integral 1 by, first of all, you have to find the tension. If you got distance x from the bottom, right? So all this weight will result in the tension there. So the tension T will be m by L x into g. That's your tension. So tension is variable. So energy in the upper half will be integral of tension is mgx by L whole square by ay into dx. This goes from L by 2 to L by energy in the lower half. If you see, you get the same terms, only the limits will change. mgx by L whole square by ay dx. This will go from 0 to L by 2. Everything else is constant. You end up with simply x square dx from L by 2 to L by integral x square dx from 0 to L by 2. Yeah, this looks like 7 is to 1. Check. Clear? Next one. Next one. 3 is to 1 नहीं रहे 7 is to 1 है ना x cube by 3 है वो तो 1 minus 1 by 8 by 1 by 8 आएगा. I hope you remember this one. Truncated cone. You're applying force F. Force F. This radius is A. I'm exaggerating the figure actually. This is B. This is the horizontal length. L must be much, much greater than B minus A. Find the elongation. Do you guys remember the result? Result is important to remember. Direct exam का question था. What is the formula normally? F L by A Y. So A का place में just substitute pi AB, geometric mean. Remember the result exam में तो that's a straightforward question. But let's derive this. Wherever you get A, put pi AB. This we have seen this in heat transfer. This is the second time. Third time you'll see in current electricity.
So what you're doing is taking the average area.
Nay, it doesn't work like that. The answer comes like that.
Actually.
So let's not make any statements like average area and all. Answer comes out like that. वो average area भी नहीं है रे. Average area will be what? Pi a square plus pi b square by 2. The answer comes as if you're taking the average radius as the geometric mean. It looks like that, but there is such nothing like that. Concrete ऐसा कुछ नहीं है. Let's see how to prove this. Maybe this would help you see. This is how we choose elements. So this is what we do here. So at a distance x, take a thin strip of thickness dx. So basically we are finding the elongation dE in the dx. So we need to find this radius r. And this r comes out to be b minus a by x by l plus a. You can refer to this in heat transfer page 24. Now in that thing, so tension is constant everywhere. So in that small section, now here the thing is changing because of the area is messed up. So this is dE. So the formula is dE tension dx by area into y. So tension is F only. Dx, the area would be pi r square y. So let's differentiate this function here. We have dr is equal to dx into b minus a by l. Same integration we did there. Substitute that thing here. F by pi y integral dx becomes L into dr b minus a by r square. R ka limits will go from a to b. Solve this, you end up with FL by pi aby. Why that length should be much smaller?
तो वो जो मतलब स्लोप का incline है that will be considered.
Basically, remember that A should be the cross-sectional area perpendicular to the tension, isn't it? But here, if this thing is too big, what will happen? The tension will be actually like this. Then you can't take this area. This area is not perpendicular anymore. Same logic what we did there, heat transfer. Clear? So you can refer to the heat transfer. This in more detail.
So in the integration, b minus a should be in the denominator, no?
Yeah, I know the answer, so I just ignored it. You're right. Clear? So that integration, I hope you can. Integration start ho gaya na max mein? This much so you can handle explore and integrations only. That is one thing. Physics may rarely see very high complex things. Clear? Next one. Next one. So we have a rectangular sheet here whose length is L, breadth is P, and the thickness is T. Young's modulus is Y. Getting it? So it's a rectangular sheet. What you did, you took this and you made it into a circular thing. This is rolled into a cylinder. Meaning side view now, it looks like this. Getting it? So you roll this into a cylinder of radius R. Now, technically, if you see this, how is this thing rolled? If you don't roll it properly, this is how it would have looked. In this, how it would look, there would be a gap. Because it's a rectangle. If you see, the outer layer has to stretch more than the inner layer. You won't get a full cylinder without stretching a bit. So this gap has to be closed. that means the sheet is actually stretched. So each layer is elongating different amounts. Getting the idea? So everything is elongating different amounts. So find the work done. So how much work should you do in order to make this into a rectangular cylindrical thing? Find work done to convert the rectangular sheet into a cylinder. Question is clear? This thing could have been done in another way also. You know, the same question could have asked in the another, instead of filling up the gap like this, we can also say like this also. This cylinder, when you compressed it, let's say the radius r is exactly till here, the center. Where 2 pi r should be equal to b, na? The circumference. So this part got compressed. So this part of the rectangle got compressed. Luckily answer will come the same actually. And this upper half got elongated. Means exactly in the center. So thickness, if you see, right? So this will be thickness of t by 2 is compressed. The outer thickness t by 2 is elongated. You're getting it?
T by 2, you just assumed it to be T by 2.
मतलब total t na, half of the cylinder is compressed, half of the cylinder is elongated.
But
So they will mention how to play with it. मतलब either way you will get the same answer though.
sir, but जहाँ पे वो like this portion जहाँ पे point of contact है, only that certain layer would be compressed ना, बाकी तो elongate ही होगा.
नहीं that's one, देखो ना, चेंज कर लिया मैंने. यहाँ पे 2 pi r is b.
अच्छा.
The inner circumference is b. मैं यहाँ पे बोल रहा हूँ the central circumference is b.
Oh, makes sense.
Getting the difference? Maybe I should make this diagram a little big. So if you see now this gap I'm saying. So this black line is B. So I can compress like this, or I can compress like this. Clear? So that thing is something which I have to explain you. Either way it works out. Let's do for this case. This is an alternate way of compressing. So in this half compression, half cylinder of this thing. So you guys try to do this and tell me whether you're getting the same answer or not. This I'll leave it to you. We will do this right now. Where the inner circumference is B, the outer, meaning there is only elongation in this case. Everything is being stretched. I'm getting a feeling both will be a little different. So let's do this. That I'll give you as a homework. Is the question understood, everyone? When you roll a rectangular sheet, you won't get a proper cylinder. That is because the inner surfaces will touch, but the outer surface ka length is little short. So if you observe here, na, एक sheet का अलग अलग elongation होगा. देख, this all these black lines. You have to stretch different amounts. I'll make it a little more thick. Now from the center at a distance x, take a thin layer. Remember, the inner radius is r, this outer radius is t. And here we know 2 pi r is equal to b. So elongation in the ring at a distance x. So normally what is the natural length? B. The natural length was b, but now you became 2 pi x. So 2 pi x minus b, which I can write it as 2 pi x minus r. B is anyway 2 pi r. Now, what is the small volume of this thing? So for this thin ring, if you take, actually it is a small cylinder. So thin volume will be the circumference 2 pi x, the thickness dx, and the length L. This is the volume. What is the energy stored? Half. Now we'll change the formula, okay? Remember what is the formula? Half stress into strain into volume. Now here I don't know the stress, right? I don't know the tension, but I know the strain. So half stress can be written as strain into Young's modulus into strain into dV, the volume. This was stress actually. Stress is Y into strain. So here the catch is that since I don't know the tension, I will use the strain and figure it out from there. I don't know the tension ka value here, so be careful with that. So this guy would be half Y strain square. Strain is nothing but delta L by L. So that would be 2 pi x minus r by 2 pi r ka square and 2 pi L x dx. X ka value is going from r to r plus t. 2 pi will cancel. So would be y pi L. What else can I keep here? 2 pi cancel हो गया, एक r भी बाहर आएगा, r square x minus r whole square, so that is x square minus 2xr plus r square x dx. Limits will go from r to r plus t. Numbers don't look that great, but this is simply an x power n integration, so simplify, you'll get an answer. So here the catches: don't use tension, use strain. Is this making sense, everyone? I feel you'll get a different answer if you do this. Because इसमें limits क्या होगा ना, minus t by 2 to plus t, r minus t by 2 to r plus t by 2, and that's a square there, so you might not get the same answer when you put the limits. I'm getting a strong feeling both will be different. So try that case also and see later on. But got the steps quite easy. Once you got the thing, you'll get it. We are rolling a smaller cylinder. Yes, right, Ishan. You're actually in the second case, you're rolling a smaller cylinder. The outer radius will be smaller. But are you getting how to do this kind of things? That has to be given, right? Normally, they have to tell you which way you want to take. It depends on how you're folding, right? You can say either way. You will say, I'm touching the center, I'm touching the corner now. Which one to take, you have to give me more information. That's why I showed you both the cases and I left it. Because if I said I made a cylinder, I could have made it anyway. I could have done this way also, right? I could have touched the outer side and I would say inner, there is a, you're elongating the inside one. You could have done anything. Clear with this? That is the steps there. So have a look at that. Turn in the page. Last one for the day. We got a wire here. This is another standard question. YAL, massless wire. Then what you did, you attached a mass M, and because of this, the wire got actually stretched. This is your X. So basically, exactly at the L/2, you kept a mass. Mass M suspended at the center of the wire. Find X if X is very, very small. Just give me a minute. Let's give it a try. Let's try this. Two mgay. I think you'll get something like energy conservation. I can't conserve energy. रे. अभी बोला ना, whenever you stretch, you lose half energy. Heat produced तो लिखा था इतना clearly. mg/4l by 1 cube root आएगा gods. Yes, sir, goofing up somewhere. Again, I'm exaggerating the figure. Let this length be theta. So this length is L/2. This distance is x. So this distance will be L/2 secant theta. So this guy is also L/2 secant theta. So the elongation will be L secant theta minus L. And the rod mg is here, block mg. So this is tension, this is tension, this angle is theta, this angle is theta. So 2t sine theta is mg. And sine theta is x. Sine theta is approximately tan theta, which is equal to x by L/2. Small angles, now we can make, for small theta, we can assume that. So from here, we got the tension mg by 2 sine theta, which is 2x by L. So tension would be, I think let's keep it in sine theta only, later we'll substitute. Now apply the formula. This also we can do an approximation. L into secant theta is 1 plus tan square theta whole power half minus L. Take out L, so tan square theta would be 1 plus x square 4x square by L ka half. minus L. Since x is much smaller, you can use binomial approximation. 1 plus 2x square by L square minus L. So this is 2x square by L. That's your elongation. Actually, इसका भी कर लेते हैं approximation. This is mg by sin theta is 2x by L, so 4x L. Then Young's modulus is equal to tension length by A delta L. Tension is mgl by 4x, length is L only, area is A only, elongation is 2x square by L. G L cube by 8ax cube. Therefore, x is mg by 8ay to the power of 1 by 3 into L. That's your answer. It's a cube root. Clear? Standard question. Any doubts on this? Clear with the steps? I'll give you homework question, try this and come. Next class we'll discuss. So we have a thin hollow shell. T is the thickness and R is much greater than T. Outside is vacuum. And let's say inside the pressure is P. So you are pumping pressure continuously inside. If B is the breaking stress, meaning if you exceed this much value, the shell will crack. Basically the maximum stress before the shell cracks. Find the pressure towards the maximum pressure before it shell cracks. Find P max. Same thing, that is still an easy one. The better question is this guy. We have a hollow cylinder. It's a long hollow cylinder. Closed long cylinder, meaning you can neglect the edges ka effect. The radius is R. Thickness is also T. Same question. So inside you filled it with a gas. Here also pressure is P. Same question. So find P max, till the shell cracks, so that it does not break. In the first case, it is a thin hollow shell. Second case, it is a long cylinder. First one is still fine. The second is a good one, the cylinder part. Do give it a try. The same question, the shell one, again, we will do in electrostatics. There I will say, there is a shell there. If I put a positive charge on it, the shell will repel each other and will explode. I'll ask you find the maximum charge. Idea is the same. So do give it a try. So next class when we catch up, we'll do this. After this, we will have something called stress strain curve. And then we'll do something on rigidity modulus and bulk modulus. You really don't have too many models on that, but there are one or two pretty good questions on those. Next Wednesday, we'll wrap up the chapter. And as usual, on Friday, we will just have a, I'll just take up your doubts if you have any. So Friday, so you guys will be in a totally trance state. Right? Let me discuss. So any doubts you have to just ask after the class. So, okay. So with that, we'll wrap up for that day. So any doubts, anything, stay back or also free to leave. So